All right, so it wants the cubed root of negative 512x to the 5th. Cubed root means we're looking for something that groups up 3 times. So you can use your factor tree if you want to do that. Remember, if it is a cubed root, it's okay that it's a negative. You're just going to pull a negative out when you do this factoring. So we're going to start with our factor tree. We're going to say 512. And I just use the smallest of the primes. So I'll start with like 2. 2 goes into 5 2 times, goes into 11 5 times, goes into 12 6 times. So I just keep doing that with my 2s until I get it down. Lots of 2s here. All right, so that would be my factoring. All those 2s, all right? I am looking for groups of 3. So every group of 3 can come out. So 1, 2, 3. Those are my 3 2s. A 2 can come out. These 3 group up. So a 2 can come out. And then these 3 group up. So a 2 can come out. All right? So actually I have no numbers that are left inside the radical. All right? Because it was a negative on the inside, I'm going to take a negative out as well. Then I'm going to look at my variable. I have x to the 5th. So I'm going to do my method where I divide. I'm going to take that exponent, divide it by 3. 5 divided by 3 is 1 with the remainder of 2. That means I have 1x on the outside and 2 x's on the inside. So I also have out here an x, and then in here I have an x squared. If I have more than one number that comes out, I multiply them. So I'm going to multiply the 2 times the 2 times the 2. So I have negative 8x on the outside, and on the inside I have x squared. You want to make sure you put your index of 3 back up there. All right. All right, this is properties of exponents. You're just going to take it. You can do numerator, solve that one first, and then denominator. I will say when I have whole numbers like the 2s, you can reduce those just like a fraction. So I can go ahead and reduce the 2 over the 2. That's just 1 over 1. That's easy. Okay? If I simplify the numerator here, then I have n's. I have like bases, right? So I have n to the negative 1/2 plus 2 because that is my like base. I add my exponents. And I do the same thing down here. N to the 1/2 plus 1 because my 2 exponents are 1 and 1/2, right? What's negative 1/2 plus 2?
Negative 2 over 2. Just kidding.
Negative, no, it's not negative at all. It's just 3 over 2, right? Or it's like 1 1/2. 2 minus 1/2 is 1 1/2, right? Everybody agree with that? So I have n to the 1 1/2 or n to the 3/2, whichever way you do it. What's 1 plus 1/2? 1 and 1/2 or n to the 3/2. What's anything over itself? There we go. And there's your answer. All right, so you want to get it in slope-intercept form, graph with your y-intercept and then your slope, and then wherever they cross, that is your answer. Wherever they cross, that is your answer. This one they want us to solve by substitution. What's the easiest variable to get by itself? The x in the second equation. So I'm going to subtract my 5y, and this will give me that x equals negative 5y plus 19. So then I am going to take that and I'm going to plug it into my first equation for x. So I have negative 6, and instead of x, I will write negative 5y plus 19 minus 7y equals negative 22. And then I'm just distributing and solving for my other variable, which is y. So I'm going to say negative 6 times negative 5 is 30y. Negative 6 times 19 is 114, I hope. Yes. Minus 7y equals negative 22. Then I am going to combine my like terms. 30y, negative 7y is 23y. I am going to add the 114 over. All right. And I will get 23y equals, all right, so 92. And then my last step is to divide by 23, which is going to give me y equals 4. All right, y equals 4. All right, once you know y, you can plug it back in right here. And we could just say x equals -5 times 4 plus 19. So -20 plus 19, x is going to equal -1. So my answer here is -1, +4. All right, so I am looking for the easiest thing to eliminate here. And honestly, the x's aren't really hard to eliminate. You can multiply the bottom by -3. I would actually eliminate the y's here because I already have one positive and one negative. And so for me, I would do the y's. So for this one, I would actually multiply the bottom one just by 2. So I'm going to leave the top one alone, 6x plus 10y equals -16. And I'm going to multiply that bottom by 2 all the way through. All right. And when I do that, I'm ready to add. So 6 and 4x give me 10x. These y's will cancel. -16 and +16 give me -10. And then I am going to divide both sides by 10. And I will get x equals -1. Once I do that, I can plug it into either equation. It doesn't matter. So 6 times -1 plus 10 times y equals -16. And I have -6 plus 10y equals -16. Add my 6, 10y equals -10. Y also equals -1. So my answer here is -1, -1. So for this one, again, this is an easy one to get into slope-intercept form. Pay attention to your positives and negatives if you do this. So for this top one, to get it in slope-intercept form, I need to subtract my 2x, which will give me -y is greater than or equal to -2x plus 3. And then I need to divide by -1. So I get a positive y here. Because I divided by a negative, I have to flip that sign. So less than or equal to, -2 divided by -1 is +2. 3 divided by -1 is -3. So when you do this for slope-intercept form, for y equals mx plus b, pay attention to those positives and negatives here. For the second one, it's simpler. I just have to subtract that 2x over. So the second one becomes just y is less than -2x plus 1. All right, y is less than -2x. Plus 1. All right, so then I'm going to graph these. For the top line, the blue one, I'm going to start at -3, and I'm going to go up 2 and over 1. This is less than or equal, so this is going to be a solid line. All right, a solid line here with a positive slope. And then my shading, because it is less than, I'm going to look and see where my y is. And I'm going to shade below that point. So I'm going to shade under this particular line here. For the second line, I am going to start at +1. And then I'm going to go down 2 and over 1. This is just less than. It is not less than or equal to. So I am going to do a dashed line here. All right, a dashed line here. So it's going to look something like this, because it does not actually include that line. And then I am going to once again shade below it, which means for this one, it's going to be on this side of the line. And then when I do that, I'll see where my wedge is, where they cross over, and you will see that this is where those two lines cross, those two shadings cross, is right here.